4x minus 6. Now, observe my denominator here. If we multiplied this together, it would be cubic, would it not? So our degree of our numerator is less than that of our denominator. We're set. We do not need to do long division here. But what we do see is this is a quadratic factor. This is a linear factor. This quadratic factor is going to demand an ax plus b. So ax plus b over x squared plus 1 plus c over x minus 1. So that's how our problem should be set up, and now we need to go for it. And this is one of those where substitution is not going to work because there is no number I can plug in here that's going to make this go to 0. No real number. No real number. Jody.
Can we take an x out of the x squared plus 1 and then just do a over x plus b x plus 1
But
plus
can I take an x out of that 1 right there? No. So if we can't, if it's not a greatest common factor that's going to come all the way out, we can't do that. Okay? So we got x squared plus x minus 6 equals, what's this one missing? The x minus 1. And this one's missing the x squared plus 1. So this is how my problem looks after I get it all set up and I have established the common denominator. So x squared plus x minus 6, I got to do FOIL right here. So that's ax squared minus ax plus bx minus b plus cx squared plus c. There's an x squared, there's an x squared, x, constant, constant. So get the system set up. So 1 equals a plus c. 1 equals negative a plus b. 1. Coefficients of those terms. Negative 6 is the constant, equals negative b plus c. So there's my 3 equations with my 3 unknowns. Now, we need to make a plan here. Here's what we can do. I can solve this one for a, so 1 minus c equals a. I can solve this one for b, and look what I've got. A in terms of c, b in terms of c. So I can plug them both in there and I'll have the whole thing in terms of c and I can solve for c. So 1 equals the opposite of a, so negative 1 times 1 minus c, plus b, which is c plus 6. So that is negative 1 plus c plus 6. So negative 1 plus 6 is 5, so that's negative 4 equals 2c. c is negative 2. c is negative 2. If c is negative 2, then 1 minus negative 2 is a is 3. b equals c plus 6. b equals negative 2 plus 6, b is 4. 3, 4, and negative 2 are the a, the b, and the c. Questions? Right here? From that. I'd already written a parenthesis, so I just let it be a negative 1 right there. So think the opposite of a. The opposite of a, well, if a is a quantity, it's as if we need to multiply negative 1 through that quantity. Anybody else? Question? Let's go back and let's write the answer now. 3x plus 4 over x squared plus 1 plus negative 2 over x minus 1. This is our decomposed fraction. We got about 7 more minutes left. General questions out there. Yes, ma'am. Let me see if I can find one real fast. Okay. Maybe this one. It's not always like super obvious. I think this one might give us one though. 2x cubed plus 2x squared plus 4x minus 3 all over x to the 4th plus x squared. Now, this one has the 4 terms. That's why I'm thinking it's going to give us a D, all right? So if we factor that denominator, it'll be x squared times x squared plus 1. So this is like a perfect storm here, where we've got repetitive factors and we've got a quadratic. This is going to give us a D for sure. So this is going to be a over x plus b over x squared. Remember, whenever we've got that repeated factor, we've got to have every descending power represented underneath it. So if we have an x cubed, it would be a over x, b over x squared, c over x cubed. Whatever that repeated power is, every power underneath it has to be there. And then finally, this is quadratic, so cx plus d over x squared plus 1. So these are the factors that represent everything in our denominator. So start setting it up here. And once again, because we've got this x squared plus 1, nothing's going to make that cancel out that's real. I actually have seen problems where you plug in I to make things cancel out, but I don't want us to take us down that road, okay? So what's the A missing? It's missing a bunch. It's missing an x and an x squared plus 1. What's the B missing? The B is missing the x squared plus 1. And the cx plus d is missing the x squared. So this is all set up. So go for it. With the distributive property, because I have one power of x on the bottom. So think about it from right down here, Emily. What's this x missing if this is the common denominator? It's missing one power of x, and it's missing the x squared plus 1. I'm basically just skipping this step of writing it all in up here. I'm just going for it right here. So ax cubed plus ax plus bx squared plus b plus cx cubed plus dx squared. X cubed, x cubed. X squared, x squared. X and a constant. Hallelujah. We know what A and B are. All right, Emily, what's A? A is 4. Hi, Miss Vargas. Is Miss Pyle still gone? No. Oh, thank the Lord. Okay. Yes, you may. So, all right, Emily, good. A is 4. Emily, what's B? Negative 3. All right. If A is 4 and B is negative 3, now let's deal with those that we don't know yet. Okay? So we know that 2 equals A plus C. But wait! There's more. We know that A is 4. If A is 4, C is negative 2. All right, only one more to go. Jonathan. We know A, we know B, we know C. What's D? So we've got B plus D equals 2. Bless you. We know that B is negative 3. I know, exactly. B is negative 3, and B plus D equals 2, therefore D is 5. A, B, C, D, plug it all back in. So 4 over x plus negative 3 over x squared plus negative 2x plus 5 over x squared plus 1. There you go. There's one with A, B, C, and D. Let's don't go there. Let's call it a day.